folks, picking up where we left off. So we've discussed the second law of thermodynamics. So now very briefly, I'm going to talk about the third law of thermodynamics. And this is actually a very short and simple law of thermodynamics in comparison to the first and second law. And stated plainly, the third law of thermodynamics says the entropy of a perfect crystalline solid the entropy of a perfect crystalline solid is zero at 0 Kelvin. And so to understand what this law is kind of saying, we need to understand the molecular modes of motion. So let's write that down. Molecular modes of motion. And this is something all molecules do. Okay, so they can translate, and what that means is they can, move around from point A to point B. Okay, they can rotate, right? So they can like spin around and round. Okay, or they can vibrate, and this vibration is typically about some chemical bond. So you can see this chemical bond elongates and then compresses, and then it will elongate and then compress. Okay, so the third law says at 0 Kelvin, another way we can interpret this, right? All of these modes become stationary at 0 Kelvin. So things stop translating and rotating and vibrating. If we think of this as a crystal, right? So this is actually solid HCl, okay? And so you notice when we have solid HCl at 0 Kelvin, right? It is going to make this perfect crystalline structure where everything is all lined up. Kind of like how we talked about crystalline structures in solids. Well, in reality, so right, if we said this is 0 Kelvin, if this was 298 Kelvin room temperature, right, it can still exist in this perfect crystalline solid, but there is going to be a little bit of movement in that crystalline solid, right? The molecules are going to want to like wiggle around against each other, okay? And that has will be manifested in an increase in entropy, okay? So third law says entropy is 0 at 0 Kelvin. And I think, yes, so that's good for this short little video. I'll see you in the next one.